between cloud security, I think, and Android development. So hopefully you've made the right choice. So my name's Katie. I'm an Android evangelist at Baloo and a Google developer expert in Android. And today I'm going to talk to you about developing for foldables and large screens. So before we start, a little bit of a caveat. I'm just getting into foldable development. I've been an Android developer for many, many years, and these foldable devices have just come out. And unfortunately, I don't own one yet. For anybody who's from my company in the audience, please tell the management team that I really need one for my work, and please buy me one. They're rather expensive otherwise. So some of the things I'm talking about here is just getting the getting started style. If you have some thorny questions for me at the end, feel free to ask them. I may not know the answer, but I will go find out the answer. So why might we develop for foldables? So if we're comparing them to phones, we're looking at a device that has a smaller screen that can then expand to a larger screen. So we've got an increased screen space that we can use, still on a device that fits in the pocket. In theory, ladies out there that have small pockets like me, nothing fits in those pockets, so in a small handbag then. There's improved multitasking. So with the changes to Android, we're able to run multiple apps or the same app side by side. So we can do some multitasking between those different apps. And that's a great use case for a foldable, where you can run things on two sides of the screen. There's also new possibilities for gaming and other new innovative ideas. So you can put the controls somewhere, use different ways of holding the device, all these things that are new. And also enhanced media consumption. So if you're watching a video on the screen, you can have the video controls somewhere else on the device and not interrupt what you're seeing. You don't have to have the little shade over the top showing you the play and pause button. And when we're comparing these devices to tablets, we're looking at a device that has more user reach. You know, some people these days, like myself, we definitely have a phone, and then we have a tablet for use at home. But it'd be great if I could have both of those things with me. And more people are likely to take on a larger screen if they know it is also their smaller screen, that they have that flexibility. And it's more portable, so they can take it everywhere. Today, when traveling up here, I didn't bother bringing my tablet. I just brought my phone. It'd be really great if I could have both options, so when I was getting ready this morning, I could watch a movie on a bigger screen rather than just on my phone. And of course, we've just had all these device releases. The Pixel Fold that Google's pushing, not quite available yet here in Australia, unfortunately, but hopefully we'll get there. And also Samsung has their offerings. I think this might be the third or fourth iteration of the Samsung device. They've been around for a while. And also other companies like Motorola have these new devices where it's more of a clamshell style rather than the opening out into a large screen. We're more going from small screen to slightly larger screen. So the question you need to ask yourself if you are developing Android apps is, should you update your app? Should you go to the effort of making these changes to make the app work for people using foldable devices? So the benefits of updating for foldables is you're giving a better user experience to your users that do have these devices. And you also have the advantage of this user experience is also available to anybody using your app on a tablet. These devices will become more and more common. So as the bigger manufacturers, Samsung, Google, create more and more devices, and if our friendly fruit manufacturer also brings out one in the future, you can guarantee that all the big companies will want their app to look great on a foldable device. And letterboxing is no fun for everyone. When you're just getting started developing for foldables, if your current app is restricted to portrait, restricted in size, you'll see that it's letterboxed on a foldable device or on a large screen device. And that just doesn't look good. The user has paid all this money for a device that has this flexibility, has a great big pretty screen, and you've cut off half of it. There's also promotion in the Play Store to think about, and your Play Store SEO. Recent announcements from Google are that they're going to promote apps that have foldable capabilities and large screen capabilities. You want to make sure that your app gets the 5 stars from everybody. There's also going to be form factor ratings and reviews. So when you're looking on a tablet, you're looking at an app, you're going to see the rating in the Play Store based on that device, not the phone style. So you don't want to have an app that has a 5-star phone rating, but then on a foldable device or on a tablet has 2 stars. You want to make sure that it's 5 stars for everybody. And we need to think about that device capability does not equal the screen size and shape. So if you're like me and been developing for, scary to think, over 10 years of Android development, you might have in the past made some assumptions. You might look at the device capabilities, such as their network capability, and then say, oh, it's got a SIM card, that must mean it's a phone. I'll show the phone layout, I'll show the phone capabilities. But if it's not, it must be a tablet. Now, these days, a lot of large screen devices also have the SIM card slot, so we know that these can communicate with cellular networks. Also, something that's a large screen device may fold to a smaller phone. So any screen size or shape can be a phone, so we don't want to make these assumptions anymore. And we no longer have only rectangular screens. In the past, we're pretty sure that it was going to have a short top, long bottom, or maybe it was, on the landscape version. Now we have a lot of square-shaped devices. We look at the Pixel Fold, the open-out version is a square, roughly. But with that Motorola device, the closed version is roughly a square. So we can't make assumptions on whether the open version is always a square or whether the closed version is always a square. We also have multiple active cameras to think about. A lot of these devices have great cameras both inside the device and outside, and you can use them simultaneously. You might be able to have some really cool applications by seeing the user's photo as well as what they're looking at. And these are available when you've got multiple screens to play with in these new devices. As I mentioned before, there's multi-window support. So we can have a sort of a tiled layout, like the image on the top right, or a more scattered, overlapped version like the one on the bottom left. And you can resize these images at any time. So it means that the app has to be able to take into account these different sizes and still be able to work perfectly. There's also the new drag and drop capability that's been coming into Android. So you can switch content from app to app. Your app needs to be able to handle this, especially if it is something that involves files or content. And this is especially useful in multi-window mode. So adaptive functionality and layout is the key thing to remember. We want to look at what the actual screen space available to the app and make sure we're taking that into account. And as I've mentioned, large screen development is not just about the visual interface. It's also about these other things, but for the purposes of this talk, I'm going to talk a lot about the visual interface. Please stay tuned for part 2 where I can go into some of these other aspects. So there's something that Google have recently also announced, which is the large screen capability checklist. And this is how they're going to decide whether your app is eligible for promotion in the Play Store. So you want to make sure you're aiming for these different levels to make sure your app gets the featuring that it deserves. So tier 3 is basic. So it's just large screen ready. It's not displaying in letterbox. So this version here on my screenshot here is displaying in letterbox version. We want to make sure that's expanded, so it's using the full version. But you just are using the screen space. You're not doing anything special. Tier 2 is the better option. It's large screen optimized. There's different layouts for both the phone and the tablet and the foldable. So we just have a different layout for each one. Tier 1, the best option, this is where it's large screen differentiated. We've got experiences unique to that form factor. So unique to foldables, unique to large screens. This is the area we want to aim for. If you want to check this out, this link here will give you all the details, along with a whole bunch of tests that you can run on your app to make sure it supports what it needs to be featured. So what do we want to do when we're designing for foldables? So if you're not a designer, and if you're not used to looking at different UIs, Google have released this showcase of all different hero experiences that you can use for foldables and for large screens. You can jump in here. It's all categorized by use case, and you can see what might be possible for your type of app. There's also a whole bunch of code as well that will give you ideas on how you can go about implementing some of these. Some of it's quite detailed, some of it's more just guidelines, but I recommend checking it out if you're starting to work on your app for foldables. So one thing we also have to think about is maintaining state and continuity. So as our device is rotating and unfolding here, we need to remember what the user's doing. So it's just the same as handling on configuration change that you might have done in the past. We need to handle rotations, folding, unfolding, handling the app start, stop, and resume. And also retaining the text that's been typed, the state of the keyboard, whether it's visible or not, the scroll position, and any media playback. Often one of my things I do with my tablet is I will be playing a board game app, but also at the same time watching a video in the other half of the screen. So I usually have these side by side. I don't want my media in my movie to stop while I'm interacting with the board game app. I want to still be able to hear that. So while we're using things like multi-window mode, we want to make sure that our app is not stopping. We're not losing state, we're not pausing any playback, our animations aren't looking janky. We want to make sure it's still working really well. So we want to make sure we maintain that continuity even when it's not in the foreground. Because an app that's in multi-window mode, the one that is not being interacted with is actually in the background, despite the fact the user can see it. So we want to make sure we have layout continuity and predictability. We don't want to surprise the user by suddenly showing something that they're not expecting, or when they're folding or unfolding their device, suddenly the app looks entirely different and they don't know where they're up to. So how do we put some of this stuff into code? So my code examples today are based on the Build Adaptive Apps with Jetpack Compose code lab. Definitely go check it out if you're looking at getting started in this. It goes into a lot more detail, into some navigation tips and things like that. I'm just scratching the surface with this, but I've used it as a basis for some of my code examples. So do you need to go and buy a foldable device? As I mentioned, I don't have one. No, you don't. You can use the Resizable Emulator. So this is recently introduced into Android Studio. I think it's in either the beta or canary versions. But it's an emulator that you can control the folding and unfolding states. It's still experimental, so there are still a few little bugs, and as you can see, it kind of jumps around a bit as you're playing around with it. This is just a gift from my experimentation. So, your mileage may vary, but it is available to you to switch between phone version, unfolded foldable, and also tablet. At the moment, you're limited to these aspect ratios that it provides, but I'm sure in the future they'll also provide versions for the Motorola devices and other things like that. It also has the availability of the hinge, so you can change the hinge and orientation states. If you have a look at this GIF here, you see the hinge in a slightly weird position. Yeah, it's still experimental, but you can still play with it and see how your app responds. And really, as I'll go into, you need to detect where that hinge is. So it doesn't matter that it's in the wrong place as long as you respond to it appropriately. So how do we go about detecting the screen size and state? We're going to use something called window size classes. So these are very opinionated from Google. They're very similar to what you might have used in the past if you were using the view-based system, where you might have different layouts in different folders, 600 dp, 720 dp for different layouts. You might have had this in the past. And they sort of follow the same sort of style idea. They've created a compact, medium, and expanded version, both in width and height. And these are independent. We used to just sort of detect the shortest width and make our judgment call based on that. But now you can actually detect the exact size and shape of your app and respond appropriately. Your app may have different requirements than what Google have set out here, and you can define your own. This is just what they've suggested, and I'm sure they'll add to this. So generally, width is more important because of our scrolling content. So most apps have, a large portion of it will be scrolling. We usually only check for the width, but you can check for both dimensions, and they are independent of each other, and that's something to think about depending on what type of app you're working on. And as I've said before, we don't want this to be used for is tablet style logic. We want to look at what type of screen we have and respond. Because we're working with larger screens, the app may actually be a smaller window in that larger screen. So a split screen could report different sizes, even though the app is working on a tablet, for example. So in this example here, in the orange there, I've got medium. The smaller app, I think this one here, the map there in purple, that's compact, whereas the actual device is medium and expanded. So you can see all of these apps that are displayed on this device would report different sizes. So we can't just make an assumption because it's sitting on a tablet that we can show just the tablet view. So we want to categorize the display area that's available. And don't forget the window size class can change throughout the life cycle of your app. At any time, the user could move these and make these larger or smaller, and we need to respond appropriately. So if you want to get the window size class for your app, if you're working in the view-based system, you can use the Jetpack Window Manager library. This is a little bit more complicated, and you do have to set these breakpoints explicitly yourself. It's much easier in Jetpack Compose. We can use the Material 3 window size class SDK and use a simple method, calculate window size class. And this is what I'm going to focus on today. So we can include this just using our normal dependency inclusion. Do use the Compose BOM if you're doing any development in Android. It definitely keeps everything in line and all the versions in check. So you can just include the Material 3 window size class as needed. So where we want to detect the window size class is in our main activity. We want to detect it at the top level as much as we can, so we know for all parts of the app what the area they have to play with. We can do this in our set content. So we can call the calculate window size class, and this is a composed remembered state. So because we've got it at the top, if this changes during the life cycle of the app, it'll get passed down into our app, and the app will update, the app will recompose. We don't have to keep track of this in multiple places. For this particular app, I only really care about the width, so I'm just going to pass down the width size class. I don't really care if the height changes because I've got scrolling content, so it'll just naturally respond. This is experimental, so even in the time of me preparing this talk, this may have changed. So you do need to include the experimental annotation here. So now we've got the screen size, how do we respond to it? So we could just be simple about this. We can just grab our window size class and then present a different layout based on that class. It's pretty easy. You know, just the compact version, the medium version, the expanded version. Pretty straightforward, and what we probably would have done in the view-based world. Just completely display the new version. We don't quite want to do that. We want to get a little bit smarter than this. We want something like this app, where it expands and contracts, different items appear, different navigation appears. This is what we want to do. So we want to respond to the screen state dynamically. What we need to think about is our fold states and our postures. So this app has normal postures, which is we're just using our window size class. This is when the device is flat, it's either folded or unfolded. We also want to consider the tabletop and book posture. This is when the device is half opened, when it's either like a book or sitting on a tabletop. We also have the type to consider, which is a separating type. I believe there's a Microsoft device that has an actual hinge in the middle that doesn't just have a crease. So we need to take this into account, looking at the occlusion, making sure that we don't put any content across that hinge. So to implement this in code, we can create an interface calling device posture, for example. We have our normal posture covering these pretty basic states. Then we have our book and tabletop posture. And then that separating posture, taking in a few more bits of information so we know where that hinge is. So we can then observe this posture using a flow. We have our device posture flow. It's a hot state flow. We've got it tied to the life cycle of the app. We're going to use the window info tracker. So we're getting this, passing it the main activity. We still want to keep the context. We're still in the top level. And we're calling window layout info. So we want to get the information of the current window layout. Again, using this with the life cycle. and then mapping this to get our folding features that we have available to us. So from the layout info, we can get the display features, and in this case, we're filtering just based on the folding feature. That is actually the only type available to you at the moment, but it's a pretty safe bet that they'll add more features, more display types, and other interesting things in the future. So once we have that information, we get the information about only the features that are present within the current window bounds. So for example, in my little example here, the purple app would not include that hinge, whereas the pink one would, because it is over the top of the hinge. So when we're reporting from the folding feature, we're reporting what's available to that app based on its position in the device. So we're only taking those things into account. If that purple app moves across the screen, we will start reporting that separating hinge. So we take this value, and then we can determine whether we're in book posture, tabletop posture, or it's separating, or we're just in our normal unfolded or folded state. So to detect if it's book posture or tabletop posture, we just need to check that half open value, and also check to see what the orientation of the device is, whether it's horizontal or vertical. It's pretty straightforward. For separating, slightly overlapping there, we can detect if the device is flat, i.e. unfolded, not in book posture, and if the separated flag is true. We can then pass these values into our interface with rectangles indicating where the hinge position is. So in a book or tabletop device, we don't really care about where the hinge is because we've got two separate displays effectively, but in a flat separating device we do care because it's sitting right in the middle, so we would get a wider rectangle. The hinge one would just be a very narrow one. So why do we care about this hinge? So a lot of our devices have creases, that's okay, but if we've got a device that's in a book or tabletop posture, we can show different things on either side of the screen. We want to make sure that no content is breaking across when it's not flat. If it is flat, we can break the content across the screen, but if it's separated, we want to make sure no content is ever broken across that hinge. And for tabletop, we want to give the content a different purpose. So in these examples, we've got a different interaction on the bottom layer compared to the top layer. So we can have that as a keyboard, have it as media controls as I spoke about before, or have something else interesting. So putting all this together, we then get our device posture flow. I'm not going to include all the code again here. And then we can pass this into our app. And we want to respond to the window width size and the posture. And that's how we can get something similar to this. So the benefits of this approach. We confine the screen size and logic to a single location at the very top of our main activity. Because we want to keep all our composables in sync. We don't want to have to be passing messages to different ones with different configurations or detecting the same information in multiple places, which is something we might have done in the old view-based system. And we want state that can be explicitly passed down to other composables. This simplifies the individual composables and makes the previews easy. If you can just pass in the static state for the previews, you know what everything's going to look like. And individual composables don't need to know about the global size. They just need to know about what space is available to them. And we don't need to create a whole new layout for each configuration. So we don't need to have a full tablet layout, a full foldable layout, and a full phone layout. Many of those components will be the same. We can just reuse them and resize them as needed. So this enhances the reusability. What about navigation? Different device postures need different navigation. So we want to navigate for responsive UIs. So we've got to think about the ergonomics of the device. Should the buttons be down the bottom? Should they be on the side? Should they be larger or smaller? We need to use a single navigation graph where each destination is responsive and we're not having different destinations for different device or window sizes. We don't want to have our navigation graph have tablet detail view, home tablet view, home phone view, home foldable view. We want to make sure that we have the same, same view for every device style. And we can use things like remember savable to retain that state across configuration changes, so we're not always losing that information. There's a great document here on the developer docs here. If you're looking into this, it really goes through all of these different points. And how might we transition between states? I'd love to show you an example with this animation actually working in code. I was trying to work on that last night to make it good, but I couldn't quite get it in the right time frame. There's an interesting thing that there's currently no way of telling the amount the device is folded or unfolded. I actually asked some of the Google developers this at IO Connect recently, and they hadn't really considered it, I don't think. You can just tell if the device is flat or folded, or half folded, sorry. I do wonder if it's because all the devices don't report the exact state of the hinge, and whether they can do that physically. So there's no way of telling, oh, the device is half folded, so you can't really base your animations based on the position unless it's half or fully flat. So for animating, I think possibly you could use target-based animation. This is something I'm still investigating, so again, see part 2 of this talk. Hopefully I'll have it working by then. But you want to look at something that as you're starting your folding journey, like as you unfold the device, your animations will be smooth to transition to the new layout and not be janky and reappear and disappear and things like that. So some of the data and architecture considerations we need to think about when we're developing for foldables. It's really tempting to only load the data that we want to show on the screen. So if you've got a news app, you might only load the article titles. You won't load the content. But on a tablet, you'd want to show that content. So you would be loading it in that case. Because these devices can be a phone 1 minute and a tablet the next, you need to make sure that you're loading all the information. It might seem counterintuitive, but with smart recompositions and other savings like that, other efficiencies, it won't be too bad. So we need to make sure all the data is available for the different sizes. That way we can do those nice animated transitions. We don't unfold the device and have to have a loading wheel while something downloads. That is definitely a bad user experience. So you want to hoist the data to the highest point possible to make it available everywhere. And this also helps preserving the user state. So if we've got that at a high point, we can use that for all our composables. And this means that the changes for the foldable and the tablet view and the multi-window views are all located in the UI. You don't have to be making changes in your view model to say is foldable, is not foldable. You don't have to do that. It's all in the UI. So it's only one place you need to make those changes. How do we go about testing these things? So there's a new API with Espresso, Espresso Device API, and this allows you to automate testing. You can include or exclude tests on test devices that have these foldable capabilities. So you don't have to run all of your test suite on every device. You can say, oh, I only want to run these tests on foldable devices or devices that are in unfolded state or folded state. Tests are executed synchronously to improve the reliability. So you don't have those states where one thing happens before another and it's confusing. You can also set specific folding features with window layout info values. And if you've hoisted the state correctly and made sure to keep all those things at a highest level as possible, it's easy to pass down these static values into your lower level composables and test them that way. This is very new. I didn't really even get to play around with it because it is so new. It's only available in the latest Canary versions. So I haven't actually updated my app to 8.2 yet, but I better get onto that. And you do need to use the newer emulators. So here are some useful links that I found during my development on this. As I said, I'm still investigating. So definitely check these out if you're getting started with foldable development and have a go at a few of the code labs. Any questions?
Thank you. What are the requirements for the phone manufacturers to support these, like for instance, angle informations or with the hinge?
Yeah,
is there anything new coming up for them?
I'm not sure about new things, but there is requirements available. Just the same as there's requirements for the camera specifications. In the past, there have been a lot of issues with some devices not reporting the same EXIF information. So there's now a whole suite of tests for camera implementations on devices. There is now for foldables as well. I think you can find at that same location, go back. I think in that compatibility checklist, there's also one for devices. So if you make sure your app follows these specifications, it should work on all the devices. As far as what they are, I don't know. I know they exist, I've looked at them, but as I'm not a manufacturer, I haven't tried implementing them all.
Yeah, because it's interesting to see. I mean, Android already used to be hard to develop for already because of different requirements, and now it seems like Google has not even set or like thought about all the possibilities yet for the development. So
yeah, well, I think that's why they might have gone for that fully flat or half opened. That's all you get to know. Because I'm guessing most devices wouldn't be able to tell you exactly how far the device is folded or unfolded.
Okay, thanks.
In the flat mode,
hang on, you better grab this.
Okay. In the flat mode, can you have a second app which was open and go as a thumbnail and the other one opens up?
Like picture in picture? I don't know, I haven't tried that. I have done, you can definitely do picture in picture, but picture in picture in the past was more for your media to continue playing, not the full app. You can definitely have apps running side by side, or you can make them a lot smaller. Some of my screenshots there, you can overlay them.
In iPad, you can basically have two apps open, but you're sort of concentrating on one app.
Yeah.
And you're not doing anything with the other one. The other one is open, but it goes as a thumbnail in the corner.
I don't think it goes as a thumbnail. It doesn't go as a thumbnail, but it can still sit there on the screen. And you can overlay, depending on what version of Android you're running, you can overlay other apps over the top of it, and it will continue running. But as I said, it will be backgrounded, even though both apps might actually be visible. Only the one that you are touching and interacting with is in the foreground. And that's why that background operation is important. Yeah. I think it would be the same as a normal Android app, making sure that you are loading your data smartly, showing loading when you need to. But as I said, you want to make sure that you're loading all the data you need for that particular screen, no matter what configuration it is actually in. So I think, being smart about how you're doing that, using things like flows and stuff like that that work really well with Compose, so that when your data changes, everything recomposes correctly. So you're not doing any of that manual work, because the more manual stuff you have to do, the less it will work in the nicely state system that currently Compose works in. Any other questions? Yeah?
Does that mean you can't use lazy layout because you want all the data?
Well, you still have all the data and it will recompose. You can still use lazy column because you have the data, and that lazy column will recompose, which would happen anyway. So that's not loading more data. You already have the data in a list. You're just requesting it and laying it out lazily.